Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken and Seth's brother Joel. We're here to hopefully show you how to approach SAT math questions, if not all math questions. So here we have a math question. It is from a practice test from the SAT that's going to be introduced in 2024. It's called the Digital SAT. And here we go with question 4. We have 16 of these things. So we have this equation, and Seth, why don't you go from here?
Okay, well, the question is, which point xy is a solution to the given inequality? I'm not going to say in the xy plane. I say in the xy plane, but I don't know. The way I would do it is I would notice that they neatly list the y values. And my approach is simply
No, the
brute
x
force.
values. The x values.
Uh-oh. That would have made a mistake.
But you would have gotten it right anyway.
No. I would have mixed up the x and the y values.
That's something I normally do. That's why we're brothers. Oh, that's horrible.
Okay.
It's a genetic defect
Bad
genetic
mistake.
defect that we inherited.
Don't worry. Okay, you have to know x. I was going to. Okay, let me then do it the first way I thought of doing.
Okay.
By brute force. I draw a table. In here, I'm going to write the value on the left-hand side of the inequality. And under here, I'll write the value for the right-hand side of the inequality for the given x's and y's. Okay, so for the y's is easy. I just copy the -1, 1, 5, and 0. And the x's, it's a little bit more complicated. I get the value by taking whatever x is, multiply it by -4, and add 4. Okay, let's do it. When x equals 2, we get -8 plus 4 equals -4. There's another 2 here, so I don't have to repeat the calculation. And I see -1 is greater than -4, so I haven't gotten to the correct one yet. 1 is also greater than -4. Wrong. Now let's try x equals 5. 5 times 4 is 20, minus 20 plus 4 is -16, which is also -16 is smaller, is less than 5. So it has to be the last choice. And let me verify it when x is -4. This is 16 plus 4, and that's a big number. Happens to be 20, which is bigger than
Wow.
0, and so
people
I'd
who
say
did
D
it,
is the answer.
so people who did it through brute force, which is a pretty good way to do it, have to wait till the last one to get the answer.
That's right. Yeah.
Ooh, yeah. Wow.
Yeah. Maybe a little bit more insight is that since we have a -4 multiplying the x, if x is positive, it's going to be pretty negative. If x is pretty positive, it'll be pretty negative. So if we want the right-hand side to be bigger, we should look for negative x's, and the only choice that has a negative x is this one, right? And so here we have -4, and then we get -4 times -4 is +16, which is really big, and a positive number is added to here, and so get very, very positive. This -4 makes this very, very
Very, very what? Did you freeze?
very, very positive,
Okay,
and the
yeah.
y value is 0,
Yeah, yeah, yeah.
which is really small.
Yeah, but almost nobody's going to approach it that way.
I don't know. Yeah, but again, I don't know what nobody would do, but again, I approach it by brute force rather than try to think too hard or spend time thinking about a pattern.
Yeah,
Uh,
yeah, yeah. Hey, let me try. Let me try the graphical approach. I've spoke before about how important it is in algebra to think in three different languages. Look at the table, which is sort of like what's that there, the table, or
yeah,
pure algebra, or the graphical approach. So let's see how
yeah.
fast. I haven't done this yet graphically. Let's see how fast I can do this graphically, and let's see if it works. Okay. So now
Okay.
I'm writing a time right now. It's minute 5:53. I'm going to do this graphically as fast as possible. Ready? So I'm gonna have to go through what all the writing is. I'm just gonna overwrite it with green. Okay, here we go. So we have here. Okay. We have y is less than. Oh, it's horrible. The thing froze on me. Oh, wow, this is not good. This is really, really bad when this happens. But anyway, I'm gonna try the graphical approach. Okay, come on. This time, don't freeze on me. Okay, y is less than negative 4x plus 4. We bring the y over, which is sort of crazy to do. We do negative 4x minus y is minus 4, right? We divide everything by negative 1, so we have 4 is greater than y plus 4x. Oh, now I got a problem here, because I really want that y to be on the other side. So I do 4 minus 4x is greater than 4 minus 4x is greater than y. Now I flip the things because I can't.
Wait, Joel. Why don't you just graph the right hand side as a function of x?
So let me finish. Maybe you're right. Okay. So that means I have to flip this. Oh, this is really bad now. I'm really just crashing here. This means y is less than this thing. So, yeah. But the thing froze. Man,
you've gone down the rabbit hole.
No, I'm not going down the rabbit hole. I wrote all the equation wrong.
All those green numbers are very confusing. Okay, it's prone to mistake.
I went the wrong way. Oh, wait a second. I am really stupid. Whoa. This is already in y equals mx plus b form. What the? Oh, I am really upset now. Oh, that is a problem. This already
y is less than mx plus b form.
Yeah, whatever. You graph this thing. It's plus 4, negative 4 slope. Boom, that's the answer. This is it. This is the answer. So, that's it. 2, 1, maybe. 0, 5 is an absolute no. 2, 1, maybe. But negative 4, 0. Boom, solid, guaranteed answer. What was I doing? It already was in y equals mx plus b form. This is the best way to do it graphically. I have no question. This is the fastest way to do it. And boy, I really screwed up here. I can't believe I didn't see that.
I see the graph now. Sure.
Wow, yeah. That is really bad. Yeah. This already is in y. It takes a second. Oh, yeah, plus 4. I overwrote it, so you have to be careful, right?
Yeah.
You just graph it. Boom, you're done.
Yeah.
Wow. Well, we both really messed this one up.
Yeah. Well, that's
yeah. But
our mistakes and your experience.
Right, but eventually I would have stopped here and I would have said I got a problem. Then I would have looked at it and said, hey, I would have done this. And then I would have said, I say, hey, there's got to be an easier way to put this in y equals mx plus b form. There has to be. And I looked at it, and then I was shocked, and I said, it already is in y equals mx plus b form. So, I don't know.
Well, the right-hand side is in mx plus b form.
Yeah.
And it's not an equation.
Yeah,
it's testing. It's a condition for pairs of numbers x and y.
Yeah, but it's like but you graph the. Oh, by the way, I'm wrong. See here, but it
Yeah,
doesn't matter. See, this is
yeah,
supposed to be a
yeah.
dotted
So
line.
why? Maybe you can ask this. What you did was you actually did graph the solution set. What you did, you marked the solution set for us by filling it with parallel green lines,
That's right. That's
right?
right.
And why did you choose that side of the line and not the other side of the line?
Because the y value, the y is the sort of like the horizontal thing. It has to be less than. It has to be lower than the equation, than sort of like the line, the equality
Yeah,
line. So
yeah,
because it's
yeah,
lower than, you do the left side. Which
yeah,
is, of course, a
yeah,
challenge for me because I sometimes get my right and my left confused. But I didn't make that mistake this time.
yeah, yeah. So that black dashed line is the plot of minus 4x plus 4. And for a given value of x, for a given value of x, a given value of x, like x equals minus 4, but here, given value of x, blah, blah, blah. The stuff that's below the points that are below the line are those for which y is less than
Right. Yeah.
is less than the y value for that.
Now,
Those below.
the way
It's below because we're looking at y as below the y's the points x y that satisfy the inequality are those for which in the y vertical direction we are below.
Yeah. So we said that already.
A minus 4x minus plus 4.
We said that already. We're not
Okay.
saying it
I
40
wanted to
times.
say vertical. I think you said horizontal.
You're right, because I always get my left and my right and my vertical and my
Yeah.
horizontal.
And also your
messed
up and your down mixed up.
Yeah, I know. Well, this
Yeah.
is, people had to have people do this, and this is where you get questions wrong,
Yeah.
which you got to be really careful about.
Hmm.
Yeah, I'm sure I'm not the only one who
Yeah.
gets messed up between left and right, up and down, and particularly in problems
Yeah.
like these. Right? Yeah.
Yeah.
Now,
Yeah, I think in retrospect, the graphical way is quicker than my brute force way.
absolutely, but the graphical way does have a little stress to it, because if you do it graphically, my 2 negative 1 is like around here, right? And that's dangerously close to the answer. So the only thing so that means that makes you a little nervous, because you may stop there. Ooh, look at that. They
Yeah.
picked the first one as it looks close. That's pretty sneaky of them. So then they think, oh, no, that's the answer. You got to check them all. This one is guaranteed to be there. Do you know why this is why does, let's see, the reason why the blue looks like it's the answer is because, frankly, I graphed this out of scale. This is a slope of negative 4, which means it is really steep. It is really steep. This is the correct thing drawn to scale, right? Steep, steep, steep. You don't normally see a slope of negative 4. Negative 4. Now you can see that the blue dot is not in part of the solution set. See?
Yeah. So in this case of a SAT question, they made it quite easy to verify. They made it quite easy to locate. To quickly locate. I don't know, a possible solution, one that would tempt you to try it. And then once you try it, you verify that it's the solution.
Oh, you're saying that you should test 2 negative 1 and test negative 4 0.
Yeah, because thing is, when you see that the only one of the 4 choices has a negative x, The negative x's, the negative x's are for the ones that are over here. And the negative x's give you points that are on this side of the plane, on the negative x side of the plane. There are more y values that set you below.
Yeah.
So, and then you think about where -4, 0 is. -4 is around, maybe somewhere like here, and then 0 is right on the x-axis,
Yeah,
which is below the line.
That's thing right there. Yeah.
Yeah. Similarly, by seeing that the y-intercept is positive, in x equals 0, the right-hand side is 4.
Yeah.
And then as x gets more negative, the minus x plus 4 gets more and more positive.
Yeah.
Right?
Yeah. Yeah.
So when you're on this side, you start out being positive. You start out y being with the right-hand side value being positive, and as you go up, you get more and more positive. And then the choice they gave you is with a y equals 0, which is the least positive, the least non-negative number. Yeah. So So again, so if you do the graphing, then it leads you to try the calculation for the correct choice first.
Yeah, no. But the other way to do it, which is of course hindsight, which is 2020, is when you look at all the answers first, sort of like in parallel as opposed to in series. You look at them and say, whoa, look at that one, guaranteed. Like, come on, no doubt about that guy.
Yeah,
just no question. So before testing this. I know Seth hates the dark writing, but we're at the end here. Before testing, then give quick review to all.
Yeah. See what they feel. Yeah.
Right. Give quick review to all before testing, because maybe there's an answer that's so obvious. And isn't that what I sort of did too? All right. I didn't actually sit there and say test. I said, let's look at them all. And I realized, boom, bingo, guaranteed.
I wonder if the SAT is going to include questions like this, where two of the choices require a very exact calculation to distinguish.
According to the test we've seen, no.
No, this is just a practice. It's just a sample question. I wonder if they will ever make a more difficult question of the same form as this, by making the test taker do a more exact calculation.
Generally, doesn't it seem like the SAT is not into people doing a lot of exact calculations, but really using their brains instead?
Yeah.
So that they don't have to do exact calculations?
Yeah.
And isn't that sort of what we want to do when you become older and you're working?
Oh, yeah.
Rather than you want to look at a problem and you want to use your brain before you spend $2 million hiring someone to do exact calculations.
Yeah.
So I don't think the SAT is ever they're gonna definitely want to see how well you can think as opposed to how well you can calculate.
Yeah. Again, what happens is, if you think better, you're more practiced in thinking in these terms, you'll answer the question quicker.
Yeah, right.
More and be less and be more likely to get it right,
Yeah.
which will give you time for the other questions.
Right.
Other questions out that may take longer time.
Yeah. Yeah, there's a lot of subtleties in this, a lot of ways to get it wrong. Oh, I forgot the other way anyone can get it wrong. Very easy to do is when you're graphing this thing, you see the -4 slope, then you graph it with a +4 slope by mistake.
Uh-oh.
Oh, that's not good. That's not good.
No.
That's not good. That is not good. That's not good.
Yeah,
M is +4. Not good. Be careful. Negative slope means things go this way, okay? That's really, really important. Really, really important.
Yeah.
Slope.
The other mistake in direction, other mistake in as kind of a sign mistake is to think the solution set is the opposite side from the green side that Joel outlined.
Yeah. Well, there are a lot of ways to get. There's a lot of left, right, up, down. Yes, no. I mean, even Seth messed up at the very beginning when he was doing it the crazy way. I didn't
mixed up X
what
and
Seth
Y.
was even doing. He was mixing up the X and Y.
What I was thinking of doing is
no one's going to understand it anyway, Seth.
No. What I was thinking of doing was avoiding writing the values of Y in the table because they were already written for us.
Fine. Nobody's. How many? Raise your hands. Well, of course, it's a silly question. How many people even thought of doing it the way Seth did? Well, maybe they thought of testing, but writing a table like that? I don't know. Maybe.
Yeah.
But also, when you wrote the table, you wrote the Y's first instead of the X's first. It was so unusual.
No, I did the Y's first instead of the X's because I wanted to detect when Y is less than the right-hand side expression.
You were writing it because the Y was here.
I'm comparing the Y of the left-hand side with the value of the right-hand side.
Oh, so Seth.
And the value of the right-hand side would be the Y as that would be if the equation were Y equals minus 4x plus 4.
So you would do
so the two entry, both the both columns of the table have numbers that are Y coordinates, which is unusual for a table.
Yeah. So is this sort of like what your logic was? Because the Y was on the left on the written down, you wanted to do the Y on your table so you could compare things pretty easily visually.
Yes. I wanted the left-hand side of the table to correspond to the left-hand side of the inequality, and the right-hand side to be the right-hand side
of the
inequality.
In terms of approaching problems, that's a very, very reasonable thing. So if the Y was on the other side, then you would have made the table the other way.
Yeah.
If it was -4x plus 4 greater than Y, then you would have put the Y on this side.
Yeah.
Yeah. Okay. Well, that's a good something to learn about how to approach these problems. Thinking from a master at math here.
Well.
Yeah. Great. Yeah, that's a good idea. Okay. So I think we're done, right? We've really killed us.
Yeah.
We've embarrassed ourselves too much on this one. So tomorrow's Thursday, which is Throwback Thursday. We go back 20 years to visit an SAT from the 20 years ago to catch a question to see what they were asking back then when the questions were more of a reasoning test than a knowledge test about math. Okay, everyone. So like us, dislike us, please give us comments on their YouTube or send us email. Comments on our email at satmathquestionoftheday@gmail.com. And if you have any SAT math questions you'd like us to go over, please email them to us at that email address. Anything else to say, Seth? We're done?
No.
We're done. Okay, have a great day, everyone. Bye.